This is the solution to Weck's 422. Okay, so for part A, here's the thing. To be the same, they must have the same domain, and there must be the same output for every input. In the domain. Well, so the domain of P, because no domain was specified, the domain of P is the natural domain of that expression, which is the reals. So that's everything, negative infinity to infinity. Whereas the domain of Q is explicitly given as negative infinity to 2, and the domain of R is explicitly given as 2 to infinity. And none of those are the same. None of these sets are the same. So, yes, it is true that they're all defined by the same expression, but they don't in the first place have the same domain, and therefore none of them are the same function. So none of the domains are the same. Domains same. Therefore, none of the functions are the same. Okay. Part B. Sketch the plots of P, Q, and R. All right. So concerning P, we could take, for example, P of X, and we could factor out the negative 3. So negative 3, then it would be, if we do that, that would be x squared minus 4, so that we could factor P like this. We could say that's negative 3 multiplied by x plus 2 multiplied by x minus 2. So P factors like so. That tells us that tells us each one of these is a 0, so that tells us the intercepts of P and the x-intercepts. So the x-intercepts, well, there's going to be an x-intercept at negative 2, 0, and another one at 2, 0. The y-intercept, we can get that by just plugging in x is 0, so that's at 0, 12. So, because P is defined by a quadratic, and because its domain is all the reals, the plot of P is a parabola in its entirety. So, the plot of P looks like this. It's got a y-intercept up here, so that's the point 0, 12. And it's got its x-intercepts down here. So this is not exactly to scale. So this would be, this is the point 2, 0, and this is the point negative 2, 0. Or at least the horizontal scale is not the same as the vertical scale, anyway. So the plot of P looks like this. So that's the plot of y is P of x. Okay, so then Q is saying that we're only going from inputs negative infinity to 2, which means that anything more than 2 we're excluding. So Q Q is just like P, except it's only part of it. So P, I'll plot all of P dashed like this. So that's in a sense the whole parabola. But Q is only the part from negative infinity to 2. So Q, in fact, looks like this. So that's it. So it doesn't continue to go down. This one goes down like that and down like that, but that's all of Q there. So this is y is Q of x. It stops there at 2. Then R, again, is defined by the same expression, negative 3x squared plus 12. So I'll again plot P dashed, and then R is just going to be part of it. R is just this other part, in a sense the part, almost exactly the part that Q isn't. So just that part. Y equals R of x. So those are the plots. Then for part C, the question is, do any of them have a compositional inverse? So P and Q, they have no compositional inverse because they're not injective. You can see that because they fail the horizontal line test. R, on the other hand, it does have a compositional inverse. Because it does pass the horizontal line test.